Hello, guys. Welcome to another episode of AI in Space Tech. And in this episode, I would like to talk a little bit about a state-of-the-art algorithm that was actually released a few months back by the Google Research Department. And if you remember, in the previous video, you can check it online. I already talked about semantic segmentation models. But the previous video was in a very basic, very important breakthrough that happened a few years back and changed the semantic segmentation, deep neural network endeavors, the models. Nevertheless, this time I'm going to be talking about a really state-of-the-art algorithm, something which is much more complicated but performs much better. The model is called DeepLab V.3+, and it has a long history of implementations. So we're gonna briefly look these. So let's get started. So I would like first to start with the paper, which you can see here. So the paper is entitled Encoder-Decoder with a True Separable Convolution for Semantic Image Segmentation. And if you see the authors here, they all belong to Google and probably to Google Research, I guess. And especially this guy here, Liang-Che Chen, has a long history on working with semantic segmentation problem. Of course, some other people like George Papandreou, and I'm not sure about the other authors, but these two authors, they've been working on this problem from at least 2015, if not even earlier. So let's dive a little bit in the paper, where I'm going to go very, very briefly through, because it's quite complicated. So to understand this paper, it doesn't make sense to read it if you haven't had any background at all with semantic segmentation, because it uses many different components such as spatial pyramid poolings, encoder-decoder, depth-wise separable convolutions, and so on. So if you read it, you won't understand much. And you always have to go back and read the original papers that these methods were actually suggested for first time. So it's a nice paper, it's a nice work, but it's quite elaborated. So I don't want to try to demystify it here. So I'm gonna avoid these, and I'm just gonna go very, very fast through the paper. You can see the performance, they're doing better than before. And here they have a few examples, but here you can see more examples of semantic segmentation as they achieve with their model, and the results are quite remarkable. That's why here on this episode, I would like to mainly focus on their implementation that you can actually find here in this link in the paper. So if you click in the link, it takes you to this page where you actually have all the source code for free for actually applying this model yourself. So the model is called DeepLab if you read the paper, and as I said, there's a long history of improvements and implementations. So DeepLab version 1 starts approximately in 2015, and practically the authors, or some of the authors, are actually working on this problem all these years. So you can imagine their algorithm performs better and better and better. And I remember back then even DeepLab version 1 was quite big success, but they continued on this line of work, and here we are now, DeepLab version 3 on February 2018. The paper, exactly the paper I showed you before, and they also have another paper based on this. So what is interesting, if you actually look now into the code aspect, is that they have two implementations. And these implementations are MobileNet version 2, which is a fast network structure designed for mobile devices. So this is for mobiles, tablets, any kind of small device you can think of, because the network is lightweight and you can use it there. Further on, you have the exception model, which is another architecture, which is a powerful network structure intended for server-side deployment. And so we're going to briefly look into these in a little bit more detail. So if you go into the GitHub link, you will also see that the authors have done some interesting work, as they provide a Python notebook for out-of-the-shelf inference. So even if you don't understand anything, you can actually use the model to perform semantic segmentation on your data by just following the details on this link, which is pretty basic. Then you have some interesting information on how to install things regarding the different 3 main data sets that the authors actually investigate in the paper. And nevertheless, last but not least, they also give a set of frozen checkpoints, which are practically the weights of the network for performing semantic segmentation, or even fine-tuning it over your data. So you can actually take the model with these super fine-tuned weights and then further optimize it for your data, and actually perform semantic segmentation of your data, hopefully with very, very good results. So this is the first link. And if you actually click here on the frozen checkpoint, it takes you to another very interesting page, which is called Tensorflow DeepLab Model Zoo. And Model Zoo stands for a set of different pre-trained models practically. So as we can see here, I have highlighted that I have many implementations, many frozen points on pascal-voc. You can see here mobile network version 2, mobile network version 2, exception with different training augmentation, different data sets, different variations of the model, and even more variations of this model. Then you have frozen points on the cityscape data set, and again you have these for the mobile net version 2 and the exception model, and again different variations here, DeepLab for ADE 20K, another data set. Again, you have here only one variation of the model, but nevertheless it's a variation, so you can use it with the exception model. And if someone wants, actually they even provide the ImageNet pre-train weights. And if you read the paper, what they do is that they don't train their model from scratch, but first they apply the same architecture for image classification on ImageNet, and then the pre-trained weights are actually used again as a basis for the architecture for applying semantic segmentation on the other 3 data sets. So they even provide the ImageNet weights, which is very, very important if you want to start from there. And here you even have more variations. So you have 3 variations of exception model of different depths, and they even give you variations of the model based on the ResNet 50 and the ResNet 101 architecture. And this is really, really nice. And I think overall, you know, the work, it's quite amazing. There's so much things they actually provide you here, the source code, the pre-trained models, everything quite nicely documented. So I mean, okay, nobody can actually complain. But I would like now to make a few points on all these things that we actually seen here now. So of course, we should be very thankful to Google Research and to the authors that they made this big effort to upload all this information, to make it open source so everybody can use it. But nevertheless, there's always space for improvement. And that's what I want to underline here by talking about a few pros and cons that I personally have regarding this code. So, of course, the first important point about the pros is that you have state-of-the-art algorithms. So you have actually the best algorithms out there which is brand new. It just came out 3-4 months ago, and you can actually use it. It's open source, you can study it, so this is amazing. You have a large repository of pre-trained models, as we saw here. So you have the cityscapes, you have the pascal-voc, you have the 8020K. These are all semantic segmentation datasets, and you even have, additionally to these, the ImageNet pre-trained weights, and this is amazing. So, I mean, what else could you ask for? You know, you can actually use all these different models yourself. Of course, this comes again with a set of different architectures, as we've seen. So you have the exception, which is the server side, as the authors suggest. If you read the previous papers, so DeepLab version 3 and so on, they also do experiments with ResNet, and we've seen in the ImageNet that they have actually 2 variations of the ResNet. So theoretically, one can even start using the ResNet architecture, even though the authors suggest that it performs slightly worse, but who knows, maybe for your data that's not the case. So interesting to have. And of course you have the mobile net version 2, which would be very, very interesting for people who want to do apps out there, who want to program lightweight applications. This is an amazing start point. What I didn't show, but it actually exists in the code, is that if you want to train the models for yourself, there's a multi-GPU support. So you can, if you have 10 GPUs, you can use practically 10 GPUs to train the model, and this is much faster. Of course, it's not 10 times faster, but you know, it's faster. So definitely something nice to have. Today GPUs are not very expensive, and many people, many institutions have many GPUs. Practically I have many GPUs in my institution, so why not using all of them? Why would I train only with one and wait? Because with bigger GPUs you can actually now have also bigger batch sizes. So this means practically your model trains faster. So nice to have. Of course, we have some documentation. We went quickly through it. There's a few hints on how to install, how to run the model on this data and so on. And this could be helpful even if you want to train on other data sets. So it's nice to have. The authors did some effort to document stuff. And of course, as I said, there's a Python notebook for inference out of the box. So you can use these, not understand practically anything regarding the model, and still run it over like your images. Of course, you're not going to be training the model, you're just going to be applying inference, but who knows, maybe it works. And what is also nice, and I didn't show, is that the authors within the code, they have used some hints, some comments on what's actually the parts of the code are doing. Probably not the most trivial parts of the code, but for example, there's a couple of lines of code before its method, so you know more or less what the method would be doing. You know, you don't have to read all the method to understand what's going on. And then what is also nice from their side is that I've seen in GitHub there been actually having some support on issues regarding running the code. So if you have some trivial problems, maybe you can find already the answer on why your code is not running. Otherwise, you can write something in GitHub in the issue section, and maybe you get a reply. Not everybody gets a reply, but some people get a reply, so that's nice. Of course, nothing is perfect, and there's always space for improvement, and that's what I would like now mainly to underline here. So there's of course a few cons points in this implementation, and I'm gonna discuss them now. So the first of my points is that there's no full documentation. Of course, I understand that's sometimes too much to ask, because the authors are researchers. They want to go on with their research. They don't want to sit down and write comments about everything, write instructions on how to run stuff, on how to apply stuff. This is a highly researched model, so nothing is guaranteed, nothing is documented. You use it as it is. So, but it would be nice to have. So I would personally like to have more documentation. It would be easier for me, which I'm running the model, which I'm training, to really understand what's going on and go on with my work faster. But maybe it's too much to ask. I understand that, but it would be nice to have. So practically the main point I want to address here is regarding the modularity of the code. So if you look into the code, it's quite complicated. So I understand high outcome comes with high complexity, but here we're talking about very highly complex code. So I've been looking in different TensorFlow applications, and this is one of the harder that I've seen. It's very hard even to read the code, because if you open one file and you're reading, then it calls a method or a class from another file, and then if you open this other file, it calls a method from another file. So it's really hard to follow. There's no one file with a model where you can read all the parts of the model, you can understand what's happening. You really have to understand first the paper, understand the structure, which is quite complicated, and then really know how to find your way between the different files and the different methods that are being called from all over the place. So I would personally like to have a more clean code, something to be easy readable and of course expandable, because when you have something so complicated, it's very, very hard to even understand how to expand it or how to adjust it to your needs. So it's very hard to make changes here. The code, in my opinion, it comes as is, and if you're not a very good expert in TensorFlow and in deep learning, it would be really, really hard to expand this, to improve it, let's say, or to adjust it to your needs. So this it's a highly complicated code, and I wouldn't recommend it to someone who wants to understand the code for didactic purposes. So if you want to understand, better look the code I suggested in the previous video on full convolutional networks, which is quite outdated, but nevertheless it will give you a very good aspect on how the models work, how TensorFlow works, how the architecture works, and all the components. Here we're talking about a very complicated code, which of course you can use it for training your model, but it's very hard to expand it. So, and the last comment I have, of course, is that all the code we've seen here is on TensorFlow. So if you are a researcher or somebody who would like to work with this, but you are actually not working with TensorFlow, but for example with PyTorch or some other deep learning libraries out there, you would have a hard time actually re-implementing the whole thing for your library. Maybe there are implementations out there, but they're not official. So the authors themselves, they only provide the TensorFlow and the frozen weights for the TensorFlow model. So this is of course again weak point where we have to mention. And with this, I would like of course to very much thank the authors of this work and for making it again openly available to us so we can work and we discuss it here. And with this, I think we come to the end of this session. I hope you learned something. I hope you're a little bit smarter, and I hope you liked the video. So if you like it, don't forget to smash the like button and subscribe to the channel. This is very important for us, for seeing that we have many viewers and that you're actually interested in the content. So if you have questions, of course, feel free to write them below in the comment section, and maybe I can even give you some hints on how to go about if you have problems running this monster. Anyway, so yeah, please give us feedback, ask questions, feel free to interact with us. We love that. So with this, I come to the end, and I hope you enjoyed, guys. So good night. Bye bye.